Hi and welcome to this demo about reprocessing. So here we will see two different strategies, namely the strategies I've described in the theory lesson, that you can apply to reprocess your streaming data. So by reprocessing, I mean two things. One thing is when your pipeline is broken and it doesn't process any data in real time, and in that case you need to restart it. Or maybe another scenario is when you need to recompute some past data from some arbitrary points like dates or maybe some other criteria. And before the demo, I will do some setup work. So start the containers. Again, I have only Zookeeper and Kafka here. And later I will also set up the topics. So to start the topic for the removal of the topic, so obviously they don't exist yet. Now the creation and another creation, and just in case I will also remove any checkpoint for this lesson. So the first scenario is the offset based scenario, so I will just close this module, and for the offset based scenario I will maybe start by generate data generator. So it's a kind of factory that will generate some visits to one of the tested topics. So the topic is variable. You can see that for offset based scenario is the raw data offset scenario topic. It will be different for the at rest based scenario, of course. And the job is very straightforward. We have the input reading, the processing logic that simply extracts some fields from the input JSON, and later the sync, so the output generation with our console sync. So here I will now start the data generator, the first execution. And meantime I will also start the streaming job. Come on. So as you can see, the streaming job is up and running. Now I will stop it and I will run the second data generator so that we generate the new rows. Okay, and as you remember, Apache Spark stores the information about processed rows in the checkpoint location. So remember, we had only one data processed so far. So that was the first execution. The second one we have new offsets, and that was the third one. And typically here I will reset the offsets. You can do it in two different manners. Either you can clean up all previous micro batches you want to reprocess. So here I could remove the offsets number 1 and 2 because I want to reprocess from the data processed after micro batch number 2, or you can do as me right now, so edit the last offset, which is a sampler version for the demo. That's why I'm preferring it, by simply overwriting the offsets in the file. So now when you restart the job, you will see that we will have again some processed records. So a few records from the data generator number 1 plus all the records from the data generator number 2. And yes, you can see that that's true. And to prove it that it's a complete restart of our job, I will run now the data generator number 3. Again, we should see new records coming to our console sync in this place. And you can see that we correctly got new items. So that was the first and probably the easiest reprocessing scenario. You simply restart a job either from the last successful processing the offset or from some arbitrary offset in the past. That you can do in two different manners, so either remove the files from the checkpoint location or simply alter the values in the last successfully processed microbatch. The second scenario is a little bit more complex because it involves some data address storage. Here I will need to involve an extra component, which is data synchronizer. So data synchronizer is an Apache Kafka consumer that reads incoming data and writes it in Delta Lake to some location on disk, on my local disk. For that case, it's worth mentioning that we don't only process the data itself, because we also explicitly load the metadata for each record, so the partition number and the offset number. What about the streaming job? The streaming job is relatively the same, except that I have here some common data processing logic that will be used by both real-time and reprocessing jobs. Again, I will maybe remove the checkpoint first. And I will start the data generator that this time you will see writes to some data address scenario topic. Okay, so maybe before I will start the jobs, so namely the data synchronizer, otherwise I might forget to do that. Data synchronizer and streaming job. Okay, and now I will run this data generator for my data addressed reprocessing scenario. So you can see I have my first microbatch process, and of course we should do the same. We should have the same for the data synchronizer. So now I will stop this job and explain to you the reprocessing logic. So in my reprocessing logic, I first loading or defining Spark session with a Delta Lake, and later I retrieve from Delta Lake all last offsets processed by the data synchronizer job. And I'm doing the same here, but for the checkpoint location. So I'm taking the last pair of commits and offsets files, and I deserialize the JSON to extract the offset position for each partition. Later on, I'm creating a filter condition for for the Delta Lake, because as you can see here, I will leverage the metadata I used previously to define the partition I want to reprocess and the offsets that will correspond to the last processing offset in the checkpoint plus the last offset which is available in the data synchronizer. So here this example relies on the broken streaming pipeline and assumption that replying this pipeline from Delta Lake, so from some data address storage, is much faster than replaying data from your streaming broker. But of course you could evolve this condition and include, for example, the time ranges, and in that case you will simply get some data and reprocess and backfill more in that context, backfill real-time data, maybe and fix some streaming query issue like late data, for example, because yes, you can imagine that you have a window that you close after 10 minutes of inactivity, but somehow you missed the late data coming in, you close the window, you didn't include the results in that, and you have some secondary pipeline that will backfill this data, this window, and include all data that could be missed by the real-time streaming pipeline due to this streaming and latency issues. But I'm digressing a little bit, let's just focus on our code. So we explicitly defining and targeting the partitions and offsets we want to reprocess. And in Delta Lake it's quite nice because it exposes some metadata layer on top of each table that will let you target this information without necessarily reading all the files. So what Delta Lake will do is to query the metadata header from each, I would say, table file, and only keep the physical reading for the files matching this criteria. So it will save a lot of I/O and should of course will automatically help speed up the whole reprocessing. So later on, I'm applying this filter. I'm reading the data in the from the storage. I'm applying my data mapping, and I calling the sync, which is different a little bit from the real-time sync I had before, but it does exactly the same thing. And in the end, I update the positions in the checkpoint file, so that when I restart, I can start from the last processed offset by this reprocessing job. So I will run now the data generator number 2. So my data synchronizer should write the records from the run number 2, so right now, and I can now start the reprocessing job that will just, I would say, fill the gap between the stopped streaming job and the real data coming to my synchronized directory. And as you can see, it correctly read all the visits from the second data generator and also updated the offsets for my topic. And now if I start the streaming job again and later run the data generator number 3, so let me just start the job, and yes, let's maybe keep it running for a while. Okay, and now I will start the data generator number 3, and typically here I should see all new records generated by this data generator number 3 printed on the console in 2 or 3 micro batches. So we have first micro batch, visit number 3 second, and the third one. So in this lesson you saw 2 different reprocessing strategies. Still, they apply to the scenario when we have a pipeline broken and we want to restart it. The first scenario, which will be maybe the most efficient for these situations when you have a very short downtime, and the second scenario where you will probably need maybe a secondary batch processing pipeline that will rely on a maybe much scalable format or storage, like for example, for this case, a Delta Lake, and will accelerate the whole process. I didn't cover the arbitrary processing scenario because it's very similar to what you have seen in the data addressed job. So here we have our files and we can define a different filtering condition that will reply the data. And this subtle difference here is that you shouldn't update the offsets, because generally your pipeline relies on the real-time information. Your pipeline shares the real-time processing code, but it doesn't rely on the same semantics. So your real-time job moves in, whereas your backfilling job for that pipeline simply replaces some past data and maybe updates this in your output location to have much more exact results. Thanks for watching, and see you in the next lesson.